get this recording. I think it's recording. Is this whole vertex form. So now go down to here, and I want you to solve this by putting it into vertex form. And then once it's in the vertex form, we're going to use our square roots. All right. So down in this one, rewrite that equation, the x squared minus an 8x plus a 7 equals a 0. And we want to put the left-hand side into vertex form. So this is the whole completing the square, where we're going to take this little plus 7 and we're going to ignore it. So think about when we did our perfect squares. Let me see if I can do this off to the side if there's enough room here. We would draw our little square in. This corner was always the x squared part of it. And then since it's a square, we took these -8s and they'd have to get split evenly between these two corners right there, telling us then that we have to have a -4 here and a -4x there. So that means we have an x and an x. And since this is a -4x, this is a -4 and a -4. Knowing that, then Omar, what completes our square right here? What's got to be this? What is it? Yeah, that has to be a 16. So I'm going to add a 16 in right here. But when I do that, now I've just created something that wasn't in the original problem. So to account for that, that's why we always subtract away the 16 from that number in the back. Then we can write this in vertex form. So this is going to be x. Notice what we have here. It's an x minus a 4 multiplied by an x minus a 4. So x minus 4 squared. When we add these constants in the back, you're going to get a -9. And then that's going to equal 0 still. That's us putting it into vertex form. So one thing I want you to do right now, go ahead and plot that vertex on the graph. So we should know what the vertex is. Go ahead and throw that on our graph. All right, and Ella, what is that point we're plotting then? What's our vertex? Good. 4 and then -9. So that we know is our vertex. All right. Now we're still going to do some work in this little square down here, this rectangle, but we now know that we can at least plot that point. All right, what I now want you to do is solve this equation using our square root. So this was our most recent quiz. In our most recent quiz, the first step was to always isolate this square term. We need to get this by itself. So in order for us to do that, we're going to add this 9 over. All right, then we get the x minus 4 squared all by itself, which was always our first step when we were solving it with the square root stuff. Once it's by itself, the reason we isolate it is so we can then get rid of the squared term. And the way we get rid of powers is with those radicals. Since that's a square, we're going to use a square root. That means on the other side, you've got to use a square root as well. This is also when we get that little plus minus. So what we end up with is an x minus 4 on the left. And then on the right-hand side, the square root of 9 is a 3. And we know that a +3 and a -3 would have worked. From there, we set up our two different equations. X minus a 4 equals the +3. And we took x minus 4, set it equal to a -3. Notice now what's going to happen when we solve these. If I add 4 to both sides, notice how we get the value of 7. Is that what we got doing the factoring? Yeah, same exact thing, same exact answer. We're just a different way of solving these equations. Then you're going to add your 4 in the second equation. When these cancel on the right-hand side, not coincidentally, we get a 1. So once again, we get the values of 7 and 1 as our solutions. So factoring is the first way that we did it. I think for most part, everybody would like to factor. That's the simplest, quickest, and most efficient way to do it. If we have to do square roots, this is how we can do our square roots with completing the square, all that stuff. And then now the new way is this quadratic formula way. All right. So quadratic formula, same exact thing. What we want to now do, or at least the same exact answers, get your A, B, and C from your equation. So you're just getting that from the original equation. We should be good at this. We just did the homework on it. So you're looking at this on your paper. to get your A, B, and your C. So write those down. All right, and Joanne, what's our A? Just one. That's the number in front of the x squared. What's our B? You're warm. Just because there's a minus sign right here, that means we have a negative 8. And then what's our constant at the end there? 7. All right. So that's our A, that's our B, that's our C. All right, then we just did the homework. We spent 2 days going over it. So we're going to now plug in. The first thing is the opposite of B. While the B was a negative 8, when we plug it in, it should be a positive 8. Then we hopefully know that's a positive negative, and then you're going to have your big square root, and then a lot of stuff goes underneath there. You're going to take your B squared, so the negative 8 squared, minus 4, and then multiplied by A, multiplied by C. And then all of that gets divided by twice A. A is a 1. All right. Hopefully, third day of doing an assignment on it, we have that memorized now. Certainly, you need to have that down for tomorrow. Okay, and just the formula memorized. Then you're going to plug or simplify all of this. So underneath that square root, it's really the only thing we can do right now. You're going to do a negative 8 squared. So that's a negative 8 times a negative 8. Again, be careful tomorrow. Even as you've done more and more of these, I will still see people mess up this sign right here. So just be careful at this step. That's a negative 4 times 1 is a negative 4. And then the negative 4 gets multiplied by a 7. So that should be a negative 28. And then in your denominator, you're just doing 2 times a 1, which is 2. All right. Continue simplifying underneath the radical now. 64 minus 28 is 36 over a 2. One of the things that we talked about, if our equation factors, and this one clearly factored because we've already did it. We did this problem right here. We've already solved it by factoring. If it factors, you get a nice perfect square under here. So what I mean by that is, don't we know what the square root of 36 is? Yeah, and that's because it factored. That's why factoring is probably your best bet if you were allowed to do that. All right. When they don't factor, that's when you're going to get the ugly numbers that we need to simplify and reduce. But in this case, we get a nice whole perfect square. The square root of 36 we know is 6. And then we get our 2 answers. And they, again, better be these 2 same exact answers. We better get 7 and 1 again. So our first answer, we're going to do 8 plus 6 divided by 2. And the way you're going to get your second answer is you're going to do 8 minus the 6 divided by 2. So one's the positive 6, one is the negative 6. So from here, this is 14 divided by 2. And then again, not surprisingly, that gives us the 7 that we knew we were supposed to get. And then we do 8 minus 6, which is 2 divided by 2. That will give us the 1 that we knew we were supposed to get. Okay. So that's 3 ways that we've done this. This next column here, I'm going to put the table on the board just to save a little bit of time. So make a little table, make an X and then a Y, and I'm going to put this into the calculator. But we're just going to fill in a bunch of tables of values. It'll save us a little bit of time. So I'm going to graph this, and then I'll show you the table. So X squared minus... So this is how we can get our answers if I give you a table of values. All right, so now here's our table. The parts I want you to write down. Start with the X value of 0. So copy that down. Let me make this nice and big for everybody. So 0, 7, 1, 0, 2, negative 5, 3, negative 8. Copy that down through 10. can't make that any bigger, so hopefully we can see that. Let me do this here. All right. Once you have that copied down, here's how we can do this if I just give you a table of values. What were our two answers the 3 different times we've done this now? We did it 3 times, 3 different ways. What was one of our answers? X equals what? Caden, what's one of them?
4.
Caden. So all these here, what was our answers here?
7 and 1.
7 and 1. What was our answers here?
7 and 1.
All right, if we go back to the factoring, we get 7 and 1, right? So 7 and 1 is definitely the answers to this. So now look at your table, and these are our x values, right? X equals 1, x equals 7. Look at your table of values on your paper or on the board now. Go to when x equals a 1. So here is the x value of 1. Here is the y value of 1. What is identical? What's the same about 1 and 7, Joe?
The y's both have 0.
Good. Look at the x value of 1. Notice how the y value is a 0 right here? Look at the value of 7. See how your y value is a 0 right there? That's why our solutions are called zeros sometimes, because the solutions are when you get your y value to be a 0. So if I give you a table of values sometime in the near future, if I did this on the quiz tomorrow, all you have to do is look at your table, and wherever you get these y values of 0, that has to be your answers. Okay? So then that's super easy if I gave you that. And then here's another 0. Your y value just happens to be a 7. So if you have those written down, I didn't write them all down because I just used my calculator, but you would have 1 0 somewhere, you'd have 7 0 somewhere. Those are your solutions. All right, those would be the points that you're zeroing in on, because those have to be your final answers. Okay. Now go to your graph. If I now graph this, notice where this graph is going to cross the x-axis at. So notice here's one x-intercept. What x value is that crossing the x-axis at? 1, right? And then what is this one, Omar? Yeah, isn't that 1 and 7? So go to your graph, plot the point 1, 7. Again, not coincidentally, since this is the x value of 1, this is the x value of 7. If I just give you a graph and ask you for the solutions to that quadratic, it's simply your x-intercept. It's wherever it crosses the x-axis. So one question, 5 different routes we can take to kind of understand what these answers are. Okay? 4 of them are old. The new one is the quadratic formula. All right, but that's kind of how all this is going to tie together over the long term. The quiz tomorrow is largely on the quadratic formula. So the back page, I'm going to leave you these. If you want to work with somebody, more than welcome to. Feel free. I am shooting you. I think it's going out at 8:20, so within the next minute, the answers to the back page are going to get texted to you. So then as you're doing them, you're going to see if you're getting them correct or not. And if not, ask somebody next to you or whoever you're going to be working with, or call me or Ms. Kubitz over, and then ask us any questions. The first 2 is a little hint. The first 2, you better get nice numbers when you do the quadratic formula, and I'm going to make you do the quadratic formula tomorrow. So do that. So 1 and 2 should be nice. And then when you get to 3 and 4, these are the ones that give you the weird square roots that need to be simplified, reduced, okay, all that stuff. All right. So go ahead and do that. The answer should be coming any minute, and then let us know if you have any questions. And then this is what your quiz is on tomorrow. Say that again.
She wants to know if you're going to give them the equation.
We'll not give you the formula. No. You should have it down by now, right? Just did the homework. Spent a couple of days on it. You'll know it. You'll know it. Okay, it should be coming right now. I thought I set it for 8:20. Yeah, maybe.